This is a recreation of a presentation originally delivered at various hamfests. I'm Michael Burnett, AF7KB. I'm the author of a series of comprehensive license preparation books called the Fast Track books, as well as some supporting workbooks and others, and I'm the narrator of our Fast Track audio programs as well. If you're a grizzled veteran of the HF bands, like Marconi here, and your ham shack's walls are already papered with QSL cards and DX awards, you're watching the wrong presentation. I mean, you're welcome to stay, but really, there's probably not going to be anything new for you here. For the rest of you, my plan is to spend about the next 50 minutes going over some practical basics about getting started in the HF side of amateur radio. We'll talk about building your first HF station, and we'll touch on some HF modes and operating procedures as well. So, let's start with building a station and some of the choices ahead of you. I think it's safe to say that there are no two amateur radio HF stations that are exactly alike. Every one of them is unique and created in response to the ham's operating goals, the operating site, and the ham's budget. And sometimes they're also the product of what I'll call ham lore. That's the misinformation you find all over those fountains of wisdom known as Facebook and YouTube. Some quick basics. When we talk about HF, we're talking about the high-frequency bands, those below the 6-meter band. Primarily, those are the 160-meter through 10-meter bands. There are a couple of more bands way down there below 160 meters, but for the moment, those are primarily experimental, and you won't find them on commercial HF transceivers. And yes, I know I should speak of the 160-meter band as MF, medium frequency, but at least in casual ham speak, those are the HF bands. The HF bands are the worldwide communication bands. They propagate over long distances, mostly with the help of the ionosphere. The condition of the ionosphere varies with the condition of the sun. For us, the best indicator of the condition of the sun is the presence or absence of sunspots. More sunspots usually equals better propagation. Sunspots vary in their frequency on a 22-year cycle, with peaks every 11 years, and valleys every 11 years. You've probably heard we're in one of the valleys of the sunspot cycle, and you may have even heard the HF bands are dead. Well, first, some good news. No matter what you may have heard, the bands are not dead. They just smell a little funny. It's true that we're in the bottom of the sunspot cycle, and it's also true that HF propagation is certainly not what it will be when the sunspots start appearing in greater numbers. However, there haven't been many days at my station, which, by the way, is nothing special, when I couldn't make some contacts somehow. So far as I know, the ARRL continues to send out those DXCC and Worked All States awards. Yes, propagation conditions have been, and at least for a while will continue to be, challenging. I won't say the bands are alive and well, but they are still alive. Here's a recent propagation forecast. You can see this wasn't a great day for propagation on any band above 40 meters. And yet, here's a picture I snapped of the dxmaps.com site that very same morning. We're looking at contacts reported on the 20-meter band. So there's plenty of fun to be had on the HF bands, and it doesn't take a 100-foot tower festooned with exotic and expensive antennas connected to the world's greatest radio to get in on the HF action. Getting on the HF bands vastly expands your ham radio world, both geographically and operationally. On HF, there's a wider variety of activities. Obviously, there's CW and SSB phone, and lots of it. There's also quite a selection of HF digital modes, some of which have become enormously popular, at least for the moment, in response to propagation conditions. You can have interesting conversations with people all over the world, or you can go for awards like Worked All States or even DX Century Club. There are lots of contests of all sorts. If you enjoy nets, there are plenty of them to choose from across the bands. Each band tends to take on its own character. That's partly because of how the frequencies are affected by propagation conditions, and partly just by the sort of semi random assortment of folks who've chosen to hang out on those bands. So, what is it that you want to do on the HF bands? Well, Mr. Burnett, I don't know. That's why I came to your silly program. I get it. It's a big smorgasbord of stuff. And the truth is, you won't know what you enjoy and what you don't enjoy until you get in and try a few of these things. You just can't tell from the outside. When I first heard about the digital mode called FT8, I thought it was absolutely not for me. It's very limited in what messages it can send. It's like a chat program that can only say CQ, my call sign, your call sign, a signal report, and 7-3. That's dumb. Then I fired up an old laptop running through my disco-era transceiver into our very inadequate portable antenna, and it turned out to be a lot of fun. So for you, since you're starting off on your journey, let's think in terms of a station that will let you experiment with a lot of HF modes and find out what lights you up. Let's add to that, too, that we do this at a reasonably modest level of expense and inconvenience, so you're not in over your head before you even get started. Now, when I say modest expense, I don't mean free. But I do mean by the time you finish building this thing, you'll have a lot less into it than these two knuckleheads each have into their bicycles and bike gear. That's my son in the front and my son-in-law in the back. I know what's in those bicycles. Let's specify that it's a station capable of operating multiple bands. And since it's well within reach, let's aim for everything from 80 meters through 10 meters. 160 meters is sort of its own animal, especially when it comes to antennas, so we're going to set that one aside for later. Let's go with modest power, say 100 watts. QRP, low power operation, is a great branch of the hobby, but probably not the greatest starting point. QRO, high power operation with a big amplifier, can come later when you have your antenna and operating skills sorted out. That's when that big amplifier is going to really pay off if you decide to go that way. We'll talk more about transceivers, but with those specifications, just about any mainstream, all-mode, all-band HF transceiver made in the last 2 decades will do the job. Let's start with what can be the most physically challenging item, the antenna. Any experienced HF operator will tell you the antenna is the single most important piece of equipment in your station. Now, to some extent, your choice of HF antenna will inevitably be dictated by the space available to install it and other issues related to that space. If you have a few acres of land and some very tall trees, no neighbors around for miles, no homeowners association to deal with, and an unlimited budget, you have a lot more possibilities than someone on a tight budget in a rented apartment with no land and a landlord who is rabidly anti-antenna. If you have the space and some tall trees or something else to hang a long wire antenna, that's what I'd recommend for your starter. You can buy commercial versions of several popular designs. If you're even a little bit handy, they're simple enough to construct, and while I won't say they're effortless to put up, they aren't major construction projects. Long wires strung on trees are very stealthy, too. You usually have to look hard to see them at all. There are 3 basic configurations for long wire antennas: flat tops, slopers, and inverted Vs. The flat topper looks like a lot of the pictures in your license manuals look, a more or less horizontal wire. In this one, the feed point's in the center, but it could be at either end or even at a place somewhere between the center and the end. A sloper runs from a lower spot to a higher spot. Usually that works out to be from the eaves of your house up to some tall object. Again, it could be center-fed or off-center fed, but I think most slopers are end-fed. An inverted V runs from a lower spot to a higher spot and back down to a lower spot. There are end-fed, off-center fed, and center-fed inverted V designs too. There are a few multi-band long wire designs to choose from. One popular one is the G5RV. Now you can buy these ready-made from several sources. This one happens to be from MFJ. Or you can make one yourself with some wire, some insulators, a length of ladder line, also known as window line, and a choke ballon. You do need an antenna tuner to make a G5RV work, and most likely an external tuner. Most tuners built into transceivers won't handle the range of SWR from a G5RV. A full-size G5RV is 102 feet long. The center needs to be at least 35 feet off the ground. It can be a flat topper. If you set it up as an inverted V or a sloper, the lowest parts need to be up at least 25 feet. As with just about any antenna, higher is better. So if you can get that center point up 100 feet, go for it. It will make the radiation pattern better, and it'll be a lot easier to tune. One more long wire. Different one here. If you have a big chunk of land with several tall objects near the perimeter, you might consider a horizontal loop. You'll need 3 or 4 or more good-sized, say 40 feet tall or more trees or other tall things on your property that are spaced a healthy distance apart. The length of the antenna is one wavelength of the lowest frequency for which you are building it. If you have room to string out about 160 meters, 550 feet of wire, you can have an antenna that'll work 160 meters through 6 meters. We're aiming for 80 meters and up, so you'll need to string about 275 feet of wire. The horizontal loop isn't terribly picky about its exact shape. It can be a square, rectangle, even triangle shapes work. The idea is to enclose as much area as possible with the wire. It isn't picky about height either. Higher is better, but there are reports of some installed as low as 10 or 20 feet high. And by all reports, they work. And it was on the internet, so it must be true. Are there more long wire antenna designs? Absolutely. But given the parameters we've chosen, is it worth spending days researching them? Maybe. By all means, learn about them, but you probably won't find a fantastically more efficient multiband long wire antenna than what we've covered. What's important at this stage is to get on the air and start learning and experimenting. You can optimize your setup later when you really know where you want to focus. Now, the basics of putting up long wires are pretty simple. Your objective is simply to safely get a hunk or two of wire up in the air as far as you can, separated from the supports by insulators. The ends should be supported by non-conductive material. Usually that's rope. You'll want to rig the ends on some sort of system that lets you raise and lower the antenna to get it tuned to the proper length. If you're using a tree or two, there are a number of ways to get those support ropes up in the upper reaches of the tree. None of them involves imagining that you have skills in climbing trees. Don't do that. My advice is to leave that to cats and to the people who get paid the big bucks to do that kind of work. If you're handy with a fishing rod, you can cast a lead weight over a tall branch, use the fishing line to pull up a stouter rope, and then use the stouter rope to support the antenna. People have been known to tie some fishing line to a bow and arrow, well, to the arrow, and get the job done. This is probably a good time to say safety first. One favorite is an air-powered gun like this one. That's advertised regularly in the back pages of QST, and that fires a spherical fishing weight. This is a device that really shouldn't be nearly as much fun as it is. If you're putting up a very temporary installation, you can use something as crude as nylon packing twine for your support rope. For something more permanent, you'll want some Dacron rope that's rated for exterior use. Be sure to hang the antenna so there's some slack. You don't want it taut when the wind starts to blow. A lot of times when I tell people who are new to this about how to put up a long wire antenna, they kind of give me this funny look like, it can't be that simple. It really can, though. Our club puts together a field operation every year for 7QP, and one of our favorite field antennas is our fan dipole for 80, 40, and 20 meters. With some helpers, it takes less than an hour to set up the whole thing from the moment the antenna comes out of the box. Now, a little hint for those of you who are in ham clubs, you can accomplish a huge amount of antenna building in a very short time with a couple of 16-inch pizzas and a cooler full of beverages, if you take my hint. Nothing tall around your house? Yeah, that's what my place looks like too. I'm in the same boat. There's nothing even close to high enough to hang a decent wire antenna at my place. However, I do have a decent-sized backyard, so I've put up a vertical. It's possible to homebrew a vertical antenna, but there's no getting around the fact that they present more difficult engineering problems to solve, and that's both electronic engineering and civil engineering. After all, they have to stand up, and stand up even in stiff winds. By the time you scare up all the various parts you need to assemble a multiband vertical, in most cases you'll probably save time, money, and frustration by simply ordering a commercially made one. HF verticals are just about universally quarter-wave antennas with loading coils. A true half-wave 80-meter vertical would tower some 132 feet in the air. That's a lot of aluminum to make self-supporting even with guy wires. Quarter-wave antennas are a lot more practical, but because they're quarter-wave antennas, they typically require some sort of counterpoise or ground radials to work. Now, that particular one you're looking at is a 43-foot 0.5 antenna. Basically, it's a 43-foot high aluminum whip antenna with ground radials all around the base. Now, here's a high-gain DX88. It's 25 feet tall. It covers 80 through 10 meters. I just had a chance to see one of these in action and to compare it on several bands with a dipole and a tribander Yagi on a tall tower. The DX88 was a little noisier, but it certainly held its own. At times, it was outperforming the dipole. It was working off about 20 ground radials that were about 25 feet long. Now, this was a field operation, so we just laid those radials on top of the ground. If you were putting this in your backyard, you could bury the radial wires, or just string them out across your lawn and use turf staples to hold them down while your grass grows up around them, and those wires will disappear. Here's a radial plate that goes at the base of a vertical antenna to connect all those radial wires. I happen to own one of these plates, and I met the guy who makes and sells them. He's a machinist out of upstate New York, and he sells on eBay. It's a very nice plate. It actually looks a lot nicer in person than it does in the picture. That DX88 we were using was ground-mounted. Other designs can be roof-mounted. There are at least a couple of verticals that advertise that they don't require radials. This is a Cushcraft R9. It advertises it doesn't need radials, but those are the radials right there. And the scuttlebutt on the internet is that even those work better with some sort of radial system installed, even if those radials are just wires strung out across your roof. It seems to improve the performance. Well, that brings us to the topic of stealth antennas. There are still plenty of zoning ordinances and homeowners association regulations out there that forbid or drastically limit what sorts of antennas, if any, we can put on our property. However, there is still hope. There are lots and lots of ideas on the web for stealth antennas. Here are a few of the more common solutions. Most towns and HOAs don't forbid flagpoles. After all, that would be downright unpatriotic, right? Well, look very closely at this handsome flagpole, and you will see some suspicious lumps. Haha, loading coils and traps. That's 05 Antenna's 30-foot flagpole antenna, and that covers 80 through 10 meters. If you have some long lengths of plastic rain gutter around your home, you can sneak an end-fed half-wave wire antenna into the gutters, even if it has to turn a corner or two. If you have aluminum gutters, well, I happen to know for a fact that there's at least one set of rain gutters in my immediate neighborhood. It's not mine, but I'm not ratting the guy out. And that set of gutters is radiating down to 40 meters. It may take a little ingenuity, but absolutely can be done. I've seen it work. Oh, you say you live in a high-rise apartment or a condo? If there's a balcony, you can stick a hamstick or a screwdriver antenna out there and dangle some 14-gauge wire down the side of the building for a counterpoise. You're not going to be a big gun contest station with that setup, but you'll be operating. Do you have a big attic? You can stick a long wire antenna up there. It won't be optimum, but it can work. So long as everything is wood up there. If you have a metal roof, you're out of luck on this one. If you go the attic antenna route, please remember your antenna is carrying some very high voltage, especially at the ends, so observe proper precautions. The League publishes a whole book of stealth antennas. It is well worth the investment if it saves your house from burning down. Or there's the magnetic loop antenna. This one's from Alpha Antennas, and there are others. They're pretty easy to build for yourself, right up to the moment that you try to find that heavy-duty, high-voltage capacitor the antenna must have to work as a transmitting antenna. The rest of it's just a couple of lengths of coax. Only the shields of the coax are conducting. The center conductor is just along for the ride. Signal goes to the small loop. That induces a signal in the large loop, and you tune the big capacitor in that white box at the bottom for minimum SWR, and you're radiating. It's kind of inconvenient. You have to retune them every time you change frequency. They're not the most efficient antennas in the world either, but they work, as countless de-expeditions can attest. Magnetic loops will work effectively just 36 inches off the ground. You can mount one on a tripod, stick it out on your patio, and operate worldwide without the HOA ever catching on. And they wouldn't have a basis for a complaint anyway because you're not making a permanent installation. You just have a thing out on your patio. One more possibility. And this one is for you if every possibility I've mentioned has been, for whatever reason, not workable. If you have internet access and a couple of pieces of the right equipment and/or software, you can operate a rig remotely, such as a club rig. A friend of mine has been a ham since 1951. Yeah, 1951. He recently moved into a living situation where there simply is not the room for any sort of antenna at all. Well, no problem. He became a member of a club that has a remote controllable station, and he operates that way. Now, I'm not going to go into all the intricacies of setting up a remote control system because there are a lot of ways to skin that particular cat. Obviously, the radio being controlled has to have computer control capability. One system works directly from your computer by running some software like the Ham Radio Deluxe remote control server. You end up operating from a screen that looks like this. Now, that software talks to an interface of some sort at the other end, and the interface talks to the remote-controlled radio. Okay, before we go radio shopping, let's talk briefly about your feed line. Now, what I'm about to say borders on ham lore heresy, so shield your ears if you're going to collapse or something. Here we go. It's perfectly possible to have a working feed line made of that RG6 75-ohm coaxial cable you can buy at Lowe's or Home Depot for about $30 for a 100-foot roll. No, but that means an automatic 1.5 to 1 SWR. Horrors! So what? 1.5 to 1 SWR translates to 0.18 dB of loss, about 4% of your power. If the rest of your antenna system is well matched to 75 ohms, which will take some work and will be a good trick, you're probably getting more signal to your antenna than half the other HF operators out there. However, by the time you buy some conduit in which to install that feed line, because you can't direct bury that stuff, and the connectors, and the matching gear you'll need at the antenna end, you'll be into the deal about 70 or 80 bucks. Now, our friends at DX Engineering will quite happily make you a 100-foot length of their 400 max low-loss double-shielded coax, complete with professionally installed PL259s on either end for 120 bucks, with free shipping. It's double-shielded, it is direct variable, no conduit needed, it only loses 0.8 dB per 100 feet at 30 megahertz. If you remember to order some waterproofing goo for your connectors while you're ordering that coax, you'll get free shipping on that too. Now, I imagine Gigaparts and HRO and MFJ will all just as cheerfully make you similar deals on similar products. If you have a shorter run than 100 feet, you can get it handled for even less. There's the small matter of how that feed line gets into your ham shack. Of course, you can go with the time-honored drill a hole in the wall and run the coax into a junction box with a PL238 bulkhead connector on the front. And some folks don't feel comfortable drilling and sawing holes in their walls. So for them, here's one clever solution from MFJ. That's the exterior side of the panel. The interior looks the same. That panel comes mounted in a cedar board that you cut to size to fit in your window. It has weather stripping and everything. About as fast as you can measure and saw, you have a weatherproof, bug-proof feed-through for your feed line, and you didn't have to drill any holes in the wall. That particular one costs about 70 bucks. If you count up the $5 connectors on there, you probably can't build it yourself for that. Notice it even includes a feed-through for your ground. Very slick. By the way, let's talk just briefly about grounding. I'm not going to go into it in this presentation because it's a whole separate presentation all on its own. But if you're going to stick a big old lightning rod up in the sky, you need to get your grounding handled correctly. And I really recommend you get the ARRL book on grounding and bonding. All right, that brings us to the subject of your HF radio. Modern HF radios are certainly amazing. Here's one now. That is the ICOM IC7851. It is one beautiful piece of high technology. And it costs about $12,500 unless you catch it on sale. Look at all the knobs and buttons on that thing. I count 97 of them, but I might have gotten lost in the middle of the count. You don't need that radio, not at this stage of your career. That's a Steinway. You still need to learn how to play chopsticks. Let me gently remind you that many years ago, hams all over the world were communicating with each other just fine with radios like the venerable Collins KWM2, a radio with a total of 10 knobs and switches, including the on-off switch and the 3-position, count 'em, 3 meter function switch. I'm not advising you to run out to the swap meet and find a KWM2 for your shack, but I am pointing out that you honestly don't need every single modern doodad and whatchamacallit to get started and operate quite successfully on the HF bands. Most of the HF makers make good, solid, entry-level HF radios that are more than adequate for your present needs. You want a radio more like this. That's an Alinco DX SR8T. Price about $500, brand spanking new. Comes with a guarantee and everything. It has a tuning knob, a volume knob, a squelch, an RIT. It even has IF shift, and it covers 160 through 10 meters. We just had one operating at our club's 7QP, and it chugged right along and did its job. In fact, it kept going when one of the more spendy radios pooped out halfway through the afternoon. For roughly another $150, you can step up to Yaesu's FT891. It covers 160 through 6 meters, so you pick up a little bonus there. It's a very compact radio. So many functions require stepping through the unit's menus, but the payoff is small size and a lot of features. Now, a lot of people take to the menus almost instinctively. Some people, they just love knobs and dials, so you need to put your hands on one of those radios and see if that's what you like. If your preference runs to ICOM, they offer the IC718 at almost exactly the same price as the Yaesu FT891, about $600. If you're up for a little risk, there's always the used market for ham radios. Now, if you choose to go the used route, I'd advise you to stay as local as possible, or at least face-to-face at a ham fest. I've heard way too many horror stories about eBay ham radio transactions to recommend those to you. You want to see that thing at least light up and make noise. It's even better if you can test the transmit side into a dummy load with a watt meter. Then you know you're buying a radio, not a project. The last major item that will probably be on your list, depending on the antenna choice you make, is an antenna tuner. That's the MFJ 949E, which MFJ claims is the most popular tuner in the world. It has lots of range, plenty of power handling capacity, 300 watts, and a new one will set you back about $200. For about $50 less, there's an MFJ travel tuner, the MFJ 945E. That one is also rated at 300 watts maximum. Okay, so you have your antenna, your feed line, your radio, maybe a power supply, and maybe a tuner. Let's play radio! Uh-oh. What are we going to do? Very broadly speaking, there are 3 families of modes widely used on the HF bands. There's CW, SSB phone, and digital modes, which use SSB. I don't mean to shortchange any of the other modes, such as AM or slow scan TV, but those just tend to be more specialized than what we'll cover here. Now, we're going to fly over CW pretty quickly. I suspect if someone is motivated enough about HF to learn CW, that someone is probably not sticking around for this presentation. CW is particularly useful in these days of difficult propagation conditions. Almost nothing punches through like CW. You also find a different crowd of people in the CW world. There are a couple of spots on the phone bands, especially 20 and 40 meters, that are crowded with a lot of, well, let's put it delicately, less than civil conversation. You won't run across that stuff if you're working CW, but you also can easily avoid it by twisting that big knob and moving on to another spot on the dial. SSB phone is probably the most popular mode on HF, and there are a lot of different ways to use SSB phone. Contests, nets, DXing, and what we'll call point and shoot, where you tune around until you find another human and then start a contact with them. I'd suggest a good starting point is nets. There are lots and lots of them on all the bands. I did a quick search the other day for 75-meter bands on the ARRL's net directory search and turned up 144 nets. When I searched all bands, I got 420. Some are specialized. There's the Medical Reserve Corps net that only fires up on an as-needed basis, and others are y'all come on very regular schedules, some even daily. Those ones I found, by the way, are listed as wide coverage nets. When you look regional or local, you'll find even more choices. The reason I suggest nets as a good starting place is because you can look up exactly when they'll be on what frequency. Saves you a lot of fruitless hunting. Pick a likely-looking suspect for you and tune in and listen. Listen from the start because that's where they'll explain their procedures. Now, I know the license exams leave the impression with a lot of people that HF operation is somehow wildly different from VHF-UHF operations, and there are some differences and some vocabulary to learn, but let me set your mind at ease. I think you'll pick up the general idea really quickly. Just keep a cheat sheet of the Q codes close at hand and of the pro signs. Here's a handy reference that I wrote for myself that has all the HF jargon and a bunch of other stuff in it. Pay attention to the flow of the net and you'll be up to speed in very little time. Formal nets provide a structured environment that can be great for a beginner. You know when to talk, you know basically what sort of communication is expected, and you have a sense of the rhythm of the net. Now, I really don't suggest starting right into contesting unless you have a good Elmer by your side. You'll get your skills up to speed quickly enough and be able to play that game, but, well, some of the players take the game really seriously. And if you're not right on top of the contest exchanges, they get all in a twist. Let's face it, some people kind of lose their minds in the heat of a competition. Heaven help you if you slow down their pace or, worse, fail to log your QSO. No point ruffling feathers that don't need to be ruffled. Get your skills together, then go contesting. Point and shoot is great if you have a little more patience and don't care so much about the structured environment of a net. Your best bet is to try to tag on to the end of a conversation. That way you'll have the call signs straight and written down. It's easy enough to tag on. Wait till they're wrapped up and then say one of their call signs, whoever's sticking around, and then say your call sign. That's it. Remember to hit those phonetics, the real phonetics. They need a moment to get your call sign straight, too. You'll be able to tell from the conversation that just ended what type of operation that operator is into. If they've had a long, casual conversation covering several topics, they're rag chewers and looking for more of the same. If it was call sign location signal report over, they're probably contact collectors of one sort or another, working on their worked all states or something similar. So all they want is the same from you. Another toy in our toy box is the digital modes. There are lots of them, many designed for specialized purposes. I'll touch on two of the most popular. One is more of a chat mode, a lot like RTTY or even AOL Instant Messenger, if you remember that. A more social mode, if you will. The other is wildly efficient and strictly about call sign signal report 73 and on to the next contact. First, let's talk about setting up for digital. You'll need a computer running a reasonably modern operating system. You don't need any sort of high-end gaming computer, though. My old laptop is my shack computer, and believe me, its CPU is probably made of wood. It's running Windows 7. The computer has to get audio to and from the transceiver. So here's what I'd call the textbook setup for that. This is what some of the license manuals teach you is how this is done. The headphone output of the computer is running into the microphone input of the transceiver. The headphone output of the transceiver is running into the microphone input of the computer. There are some inherent problems with this setup. First, there's no push-to-talk control anywhere in that loop, so you either have to manually switch to transmit mode, or do what I do, which is run in Vox mode. Second, the audio outputs of both devices are at line level, that's around a volt, and the microphone inputs are at mic level, typically around a millivolt. That's 30 dB of difference, so setting volumes properly is often a delicate operation. Now, I guess there are some people running with that textbook setup, but I don't know any of them. Here's what I'm running, and more or less what everyone I know is running. That box in the middle is called a signal link. That's one brand of them. It replaces your laptop's sound card. It plugs into a USB port on the computer and into your radio somewhere. Tigertronics, who makes the SignalLink box, makes a wide assortment of cables for the connection to your transceiver. You just order the right cable from them. Well, now that your computer and radio can communicate with each other, the next step is to get the right software running. For the first mode we'll talk about, PSK31, FLDigi is some free software for that mode. There are some others too. Ham Radio Deluxe also does PSK31. Now, if you're not familiar with Ham Radio Deluxe, it's quite the software package. It does your logging, handles multiple digital modes, integrates with the WSJT software suites, and a whole lot more. It is not a free program. At the moment, it's $99.95. For the very weak signal modes that are very popular, at least for the moment, including FT8, it's the WSJT-X suite of programs, and that is a free program. Let's start with PSK31, the one that's a lot like RTTY. It's a keyboard-to-keyboard conversation mode. PSK31 means phase shift keying 31 baud. Let's say propagation is looking at least fair on the 15-meter band. You'd tune your radio to 21.230 megahertz. That's the unofficial PSK frequency for that band. And you can find all the frequencies for the different bands very easily on the web with Google. Set your radio for USB. Unlike RTTY, all the digital modes run on USB. Some won't work any other way, but the rest run there by convention. You probably will hear a lot of static on the frequency, but don't worry about it. PSK31 is made for fair to poor propagation conditions. You fire up the PSK31 software of your choice. Let's say you opted for Ham Radio Deluxe. You get a screen like this one. FLDigi's is similar, by the way, but with a lot fewer snazzy features. PSK31 has a very narrow bandwidth. It's skinnier than CW. So there are going to most likely be a lot of signals right around 21.230. Since it operates with audio tones on USB, different audio tones create different offsets from 21.230. And if you look, you can see about 8 signals in this 3 kilohertz worth of waterfall display at the bottom of the screen. Your computer will handle the offsets. You'll leave your radio set to 21.230. When you click on the waterfall display, your software will start decoding that conversation, which you see in the window above. Now, you can sit and monitor PSK31 conversations until you get the hang of how they go. While the software can be a little confusing at first, at least it was for me, but then I'm easily confused, the operating procedures are really pretty straightforward. When you get your nerve up and you find someone calling CQ, answer them. You're off and running on PSK31. Now, PSK31 conversations use a lot of lowercase letters and abbreviations. The lowercase is because PSK31 uses what they call varicode. You might remember it from your license exam. Like Morse code, it uses very few symbols to represent the most common characters, so lots of capital letters, which are less common and use more symbols, slow things down. You don't see it in this picture, but there's a lot of the same sort of abbreviations as you'd find in CW or RTTY. I think any of us who text on our phones regularly are used to sentences like OKLOLCULTR. You'll catch on quickly enough since the same ones get used over and over. As you can see from the picture, one doesn't have to be an expert typist to use PSK31. In fact, there are macros built into most of the software packages that automatically send things like CQ, 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 DAF7KB, and other common text strings. PSK31 chugs along at a send rate that's about equal to average typing speed. You don't have to be super typist at all. You can see a great video by Dave Kassler, KE0OG, of a sample QSO on PSK31 if you look up PSK31 on YouTube. The bad news about PSK31 is that so many people have migrated over to using FT8 that PSK31 conversations are getting a little scarce. But they're still out there, and I think they'll probably pick up as propagation conditions improve. Then we come to the latest officially released weak signal mode, the notorious FT8, what some people say is the end of ham radio as we know it. As a technical achievement, FT8 is amazing. If PSK31 is a weak signal mode, FT8 is an invisible signal mode. It's quite capable of pulling out signal with a signal-to-noise ratio in the single digits. It's specifically designed for poor propagation conditions using low power through a marginal antenna. You do not need to fire up a big old 12-element Yagi on a 150-foot tower with 1,500 watts to make this stuff work worldwide. The first time I ever tried it, I was running about 50 watts on 20 meters into a buddy pole set out on our patio about 12 feet up because it was a windy day and I didn't want my buddy pole to blow over. Now, buddy poles are great, and we've had a lot of fun with ours, but that is not what you'd call a big dog setup for 20 meters. It was a rotten propagation day, too. Paul Herman's little solar weather widget said poor conditions on every band at all hours, and believe me, it was right. I fired up the computer and I tuned in 14.074. I flailed around with the software for a little bit, got it working, and had a contact within a couple of minutes. It was, well, okay, it was all the way to Marysville, Washington, about 5 miles from my house, but hey, contact! After that, I had Wisconsin, Michigan, Belize, and Portugal all within about an hour. FT8 comes to us from the great guru of weak signal modes, Joe Taylor, K1JT, and Stephen Frank, K9AN. In fact, FT8 stands for Frank Taylor 8-tone frequency shift keying. Your setup for FT8 is the same as for PSK31. You don't have to move a single wire. You'll be running the WSJT-X weak signal suite, which you can download from Joe Taylor's site at Princeton University. Here's a screenshot of it. On the left, you see all the activity in the band, and when it's live, you'll see incoming calls come in the bottom. If you squint real close, you can see WA6GXQ is calling CQ. It's the second one from the bottom in that left-hand panel. If I was to double-click on that call sign would show up over in the right-hand window, and my computer will send a response to that CQ. This operator that you see here has the software set to auto-sequence, so if WA6GXQ responds to my answer, my computer will just step through the standard messages in the window on the right, that white window. It even auto-generates a signal report and wishes the other operator a pleasant 7-3 when we've finished exchanging signal reports. Now that's about it for in-depth, intimate conversation on FT8. It's about making contacts, period. It's possible to hack in tiny little messages, but I've never personally seen it done, and doing so sort of defeats the efficiency of the mode anyway. Now, one thing you must do for FT8 is to synchronize your computer's internal clock to a good time standard. There's a website called time.is that will help you with that, and there are programs you can install that will automatically update your clock. Windows 10 does a pretty good job of keeping your time accurate, but use time.is to check it out before you start transmitting. The reason for the accurate time is that FT8 operates with precisely timed 15-second slots of listening and then transmitting and then listening again. If you're not synced up, you'll be transmitting when the other station isn't listening and vice versa. All right, so there's your whirlwind tour of getting started in HF. Now, before we close up, I have some bad news here for any perfectionists who are with us, I know. I know you folks. You're very concerned that you're going to make errors, and everyone will know you're a beginner. Well, brace yourself. You will. The good news is fully 95.2% of all hams, measured statistically, are good-humored and forgiving, especially if they know that you're new to this aspect of the hobby. As for the other 4.8%, well, you aren't going to make them happy anyway, and they will survive their traumatic encounter with a newbie. Forget about perfection. This hobby's about fun. So get out there, get on the radio, have some fun, and do some wonderful things. Thanks so much.